All right, hello guys, welcome back. We're going to continue our discussion about the unit circle and exactly how we use it and how useful it can be. So as you can see, we have a completed unit circle up here on the screen. Remember guys, you should be able to do this from memory very soon, if not right now. All right, your job was to practice that, and here is the real payoff. So how do we use this thing called the unit circle? All right, well, before we were kind of using our trig functions to tell us the lengths of triangles, or we could use it to perhaps tell us a certain value of a degree here or there. Now, remember, I told you the degree is kind of like the archaic way of us measuring the distance around a circle. The radian is the true mathematic way, and it's going to be the way that we use pretty much predominantly from here on out into the future, especially in pre-calculus and calculus. Okay, so let's talk about how our trig functions fit into this. Now remember, we kind of looked at creating a right triangle right here on the screen. Okay, so we said that this guy right here along the ray that makes a 45-degree angle, he was our hypotenuse, all right, so r, and since we're dealing with a unit circle, r is of course 1. Then we said, well, this guy represents the x-coordinate, and this guy here represents the y-coordinate, right? Well, sine of theta, if we were using our triangle trig, was the opposite side, which was y, over the hypotenuse, which is 1 in this case. So sine of theta actually equals y. Well, if I wanted to ask you what's the sine of 4 pi, this isn't a lesson of actually plugging sine parentheses pi divided by 4 into the calculator. This is just knowing that, oh, the sine of any theta value is just the y-coordinate on the unit circle. So immediately you should be able to say sine of 4 pi is root 2 over 2. It's that simple. What about the sine of 5 pi over 4? Go ahead and take a few seconds to figure that out. All right, the sine of 5 pi over 4, you should have came up with negative root 2 over 2. Now, the over 4s are kind of simple. Obviously, you're going to have some form of root 2 over 2, whether it's negative or positive. You should be able to figure that out. What if I started to do, let's check out the cosine of pi over 6. Now, remember, if sine of theta is the y value, cosine of theta has to be the x value. So what is the x value of the coordinate that intersects with the unit circle at pi over 6? Take a few seconds. Figure out what that is. If you need to press pause, do it. The answer should have been root 3 over 2 because that is the x-coordinate at pi over 6. All right, let's try the cosine of 5 pi over 3. All right, the cosine of 5 pi over 3. Take a minute or a couple of seconds to figure that out, or press pause if you need to. Now, remember, the cosine is the x-coordinate where that terminal ray intersects with the unit circle. So if we go all the way around to 5 pi over 3, which is right here, we notice that the x-coordinate is 1/2. So the cosine of 5 pi over 3 is positive 1/2. Tangent is where it can get a little tricky. All right, and let's talk about the tangent of pi over 4. Remember, the tangent is the opposite divided by the adjacent in triangle trig terms. Okay, so when we're talking about that here, we need to take our y value and divide it by our x value. Well, the y value at pi over 4 is root 2 over 2, as we talked about in the very first example. The x value is, again, root 2 over 2. So if I have a number divided by itself, of course, the answer has to be 1. So in some ways like this, tangent can be a much more easy function to deal with. But what if I have, or would have, let's say, tangent of 5 pi over 6? All right, tangent of 5 pi over 6. What's the y value? Give you a couple of seconds. The y value at 5 pi over 6 is 1/2. What's the x value at 5 pi over 6? You should have said negative root 3 over 2. Now, if I were to go ahead and finish that off by changing this to a multiplication of fractions instead of division by fractions, you should have something like this. And then we multiply those across. Obviously, the 2's cancel, so I'm going to get negative 1 over root 3. Remember, I can't leave root 3 in the basement, so I need to rationalize top and bottom. Go ahead, negative 1 times root 3. I get negative root 3 over 3. All right, and that's one way tangent can be a little more tricky than the average problem. All right, you should be able to use those to go and find any value using the 3 basic trig functions. Now remember, there are the reciprocal trig functions too. So if I had the cosecant of theta, remember that would be 1 over y. All right, if I had the secant of theta, it would be 1 over x. And if I had the cotangent of theta, it would be x over y. Now, you should be able to go and find the sine, cosine, tangent, cosecant, secant, or cotangent of any radian value here on the unit circle, whether it's from 0 all the way up to 2 pi and beyond if we're going to start looking at coterminal angles. Okay, so you should be able to finish your worksheets. I do believe they are the 10.2 versions, and there's also an A and a B of that. So you should be able to go through and figure out exactly what those values are without using a calculator. Okay? So good luck with that, guys, and I will talk to you later.